How did I do this? Come on, Borg. Right. Ah, okay, it works. Cool. Hi, Laris. Can you hear me? Okay, good. Can you hear any music? Hi, Jobat. Okay. Yeah, I'll need to work on this. Right. Jesus Christ. I've been fighting with my setup again. You know, I actually I switched to i3 with XFCE as the desktop manager. If I share my OBS, it's okay. We can do it later on. Hi, Robin Gear. Hello. So yeah, Loris, I'm on i3 now, so basically I had to rework everything that I have. Can you guys see this? Is the font okay? Is it readable? Yo, Firefox. Looks fine, yep. Okay, cool. Yeah, it is afternoon actually, yeah. Okay, so today what I want to do, I'm gonna be going, so basically Yahim came up with this cool thing, a new API for the register manager called freeze unfreeze. And basically today I want to port as much as possible of x86-64 codegen to this new API. And while at it, maybe fix some bugs, make more behavior test passing for x86-64. Basically, you know, go as far as we can without actually tweaking the linker. I have something cool to show you as well, since everybody is here. So wait, am I on my... Yeah, okay, I think so. Just to be sure. Let me fetch origin quickly. I'm going to show you some cool stuff that we have, that I've actually added recently, and it's it makes the entire experience with Stage 2, even the native, well actually no, only the native backend, a lot more pleasant. So bear with me a second. I think I might have to do this first. Ta-da-ta-da-ta-da, build. Yes, it's everything with debugging. I'm actually pretty proud of this. Like, I mean, Dwarf is pretty well documented, but you know, they use like obscure languages as the example, like Fortran and Ada. Like I'm not a rocket scientist. I don't use Ada, so it's kind of obscure for me. And C is, sometimes they do mention C a little bit. You're like, okay. And actually having C would be a lot. You know, it would make more sense, especially for me and Zig in general, right? Because we're pretty close. Even C++ would be better than Ada or Fortran. Like, come on. But anyway, yeah, we have the debug info, even including the bug lines, is actually working now. So there are a few things missing. Some things in the front end, quite a few in the linker, and I'm talking about else linker. Mako doesn't have it yet. I need to work on this. Oh, that was a mistake. I should have done it before. Sorry, I'm actually building in release so that we don't have to wait ages to build stage 2. By the way, Loris, I did turn on the streamer mode in Discord, and I'm still not being shown as streaming. It's weird. Don't know why. Bork. No. Oh well. Oh, come on, come on, come on, come on. Very true. I bloody hope that Zig is gonna be much faster than this. This is ridiculous. This is building stage 1 in release, but come on. It's not even rebuilding everything. Maybe I should hook up mold for linking of stage 1. Oh my god, this is embarrassing. Is it like stuck? No. I'm gonna have my tea in the meantime. Oh, what machine is this? This is actually Ryzen 7 48 something H. Can't remember. It's got like 16 threads. I've got 64 gig of RAM. I've got a very fast NVMe solid state drive. So yeah, this is the machine is okay, right? It's pretty fast. But this is ridiculous. I actually don't remember it taking so long. I wonder if this is because I'm streaming at the same time. Yeah, I think it's relocating itself. I'm gonna give it another go, and then if that doesn't work, I'll just like wipe build directory and just rebuild it again. Maybe there is some kind of a clash between the latest master and what I have. Oh, there is stuff happening on all the cores. Hi, Ahim. I didn't know, Loris. I didn't even tweak stage 1. I don't even know what the hell is going on here. Seriously. Actually, do you know what? Yeah, I'm gonna build. Okay, why not? Let's try it. You see, this is actually going. This is working fine. Oh yeah, who's streaming today? Oh, nice. Yahim. Oh, right. Yahim is streaming today. Cool. Yeah, I saw that Tiger Beetle was live right now. Nice, Laris. Yeah, take a break. Oh, please work. I don't want to spend time on stage 1. Oh my god, I'm hexed. Haunted. This is not working. Why? Yes, I'm making a release build of stage 1, correct. I'm actually not doing anything fancy. Wait, maybe I still have the... Oh, still got Zeg, maybe it's gonna work. But yeah, if this doesn't work, if it doesn't go till the end, I'm just gonna kill it. Yeah, but that long, Joachim? Like, this is freaking ridiculous. Like, I don't remember, I don't actually remember it taking so long before. Maybe it's because of OBS is running? But then why would it? Like, I don't know. Yeah. Well, I don't remember it taking that long too. Unless, did we learn something that might have triggered it? Let's have a look. What? Just the parser, that's fine. AST stuff. Could that be it then? This index. No, I think something is definitely wrong. It's like it's somehow entering an infinite loop. I don't actually know what it's doing now. I'm not sure what it's linking, to be honest. Wow, I'm not sure. If it's linking, it should be using what, system tools, right? Right. Screw it. Oh no, I was building stage 1. But Agatha SW. So how long did it actually take for you then? Why is my browser not inside i3? What browser? There it is. Oh, you mean why do you see my... Oh no, I'm changing the the space, whatever. So okay, cool. Thank you, Ahim. 3 minutes. Damn. Well, it works. Okay, that's fine. So anyway, oh, this Yahim, you're gonna love this. Let's pick something that I was actually battling with Yahim before. Oh, there we go. With fancy formatting, we have, what do we have here? We have a structure in the global scope. We have a function that's actually nested within the struct called foo. Takes one argument a. It's formatted in a fancy way. We have obviously main and print, and then the point is we should have every single debug line properly worked out here. Let's delete this. I'm actually gonna nuke cache too, just to prove that it actually works. And let's build it. We can actually do it with watch, in fact. Let's do that. Update, why not? Then DDB, simple. Wanna break in foo, line 6. Wanna break in main, no, break in main. Wanna break in print. 11, 15, this looks promising. Let's run it. Main is first. As you can see, actually, oh, this is something I need to fix. I think we should break. I'm actually not sure where we should break. Should we break? This is the first program counter just after the prologue. Meh, we'll see. Anyway, so yeah, look at this. We have the line numbers for main and foo. So let's keep going. It's print. Oh no, actually it's foo. We break at line 6 in foo correctly. So this is with formatting and everything. If we keep going, we're gonna break up at, yeah, okay. It's the first, yeah, it's just the first instruction after the prologue here is actually preserving some of the Kali saved registers, but I'm not sure. I need to have a look how LVM actually does it. See, I don't know. Maybe you should immediately break here rather than break here and then, you know, do a next. I'll need to have a look. But anyway, break at print, correct. And then again at print, and we exit. Cool. So this has been fixed now. Now we are in the watch mode, remember, so we can actually do incremental updates and different shenanigans. We're actually going to move main with print. So the debug lines should change, but we're actually not going to touch anything within the body. So actually what is happening, we should only be changing the offsets for main and for print. For minutes. Yeah, I think for me it was taking far longer, right? Than 4 minutes. Yeah, after the stream is done, I'm gonna have a look why. Anyway, so but let's focus on this here. So I swapped main with print, hit update, and now we expect all the lines to be working again. So break at main, line 23, break at print, line 11, break at foo, line 6. Let's see if it works. Ta-da! pretty sweet, right? So we have actually debug lines working for incremental updates too. There are some quirks that need a couple more fixes in the front end side that we haven't handled yet. But I had a discussion about this with Andrew, and he's gonna land this, or at least he promised. So so this is actually looking really good. So if anybody wants to experiment with stage 2 on Linux, you should have debugs like correct debug output out, which is pretty good. And the other thing I can show you here as well, since we're here, I have this one too. This one is, what is it? It was like a dummy one for me. I actually pulled a couple of tests for actually passing in slices as arguments. And this works pretty great too. So let's do it in incremental mode as well. Update, why not? And then we're gonna break at some array lengths, get array len on main. Main, get array len, some, and run. So we're at main. It looks pretty good. Continue. So also breaks at the correct place. Now my favorite, we actually get printing of slices now. Yeah. I mean, I could do it all day. You can preview exactly what's inside it. What is the length? 5, yeah, until 5, right? It obviously works for having 2 arrays too. So, oh, and it behaves exactly the same as you can see it in output produced by LVM. It prints actually the garbage from slice B, because it is actually garbage. I think it's undefined. We populate it with Poison, but it's U8. So we correctly actually annotate the types as well. Okay, oh, it's not running with the queue. And then if we tweak the formatting as well, remember we are still in incremental updates mode. So do that, and then we should expect to break correctly in summary lens at line 29, around, like roughly. Summary lens. Or 28, yay. So yeah, it's working. This is very satisfying. I don't know about you, but it's really satisfying. Okay, enough of this. Oh, and this should obviously work for anything else, because the changes are actually, the fix was an AST gen for line numbering, because we were actually adding two absolute values together, which was wrong. So that's been fixed, and the rest of the thing is actually going on in the linker. So no changes are required on the codegen side. Just an FYI, Yahim. So that should work for ARM too. Right, okay, so I was dealing with freeze Rich here. Oh, by the way, since you're here, Yahim, I wonder if we can, like, I wonder if this is, I guess this is due to the fact that we have MC value. I wonder if I can add like a helper function maybe to MC value to basically, if it is a register, just freeze it, but freeze it for the duration of the scope or something. Because this if register, freeze, defer if register, unfreeze, kind of looks a bit clunky. I don't know. I'll need to think how we could actually improve it. Oh, and so you left a couple of notes here, like exceptions are deprecated, right? Yahim? So does that mean, so try alloc is like try alloc and then alloc that actually stays, right? But just this argument is going away, Because we won't need it. Is that your plan? Because I think that would it makes sense to get rid of the exceptions altogether, right? Because since we have freezing, and okay, right, cool. So basically one argument less. Okay, cool. And I think x86-64 is the last one left. Yeah, gotcha. Yep, makes sense. Okay, so while I was doing this, and I think this actually still works. I don't think I broke anything. The test should still be passing here. Yes. But while I was doing some of the stuff here, where's cast? Let's go into cast and then x86. There was a case I found that is very weird and we should probably look into it. Oh, I think it's that one. So just comment that out for the minute. So this is implicitly cast indirect pointer to maybe indirect pointer. I'm not sure whether the casting actually works fine in x86-64, but this is producing a nasty panic and I would like to get rid of it. And the panic is happening in aircall, my favorite function, and getReg. Yay. So we spell, okay, let's have a look. Codegen 8 for auction, get resolved inst value. In spill instruction. So basically, so this means we are actually spilling an instruction here when we call getReg. Okay, and this is from aircall. So let's go through it. Aircall line number. Where is it? I'm lost. 598, 598. Oh fuck. 2250. Okay, right. What is this? Oh, it's for arguments. Nice. So we are. Wait a minute. Should that be not like getReg assume free? This is silly. We already have the register. Oh, unless we want to preserve it. What if it lives longer? Still though, it should. Right, yeah, exactly. So we might have to spill it, yep. Oh yeah, hi Lotus, welcome back. No, I didn't, I gave up. I had a release binary, like pretty fresh lying around, so I just used that one. I'll need to investigate why it stopped working for me. Right, yeah, so we can spill it, which is fine, okay. Okay, so we actually do, why do we panic then here? And we panic here, get resolved inst value. I wonder if this is something I did before. So MCU is actually dead. Why is it dead? Okay, let's try it with actually I don't want to overwhelm us with too many debug output, but like logs, but that's fine, I guess. Oh, so maybe this is actually coming from somewhere else. Yeah, I wonder. Stage 2 zig test. I wonder. So let's just do it in isolation. Let's see what happens. Don't need that either. Yep, okay, and actually we can get rid of this for now. QR. Yeah, okay. Oh, crap. Cast indirect. Okay, what's up here? What? Uh-huh. This is fascinating. What the hell is happening here? $38. 40 constant decl ref. Is that a combination of things? Unused, which one is unused? R then. This is the R thing. Yeah, I bet it is. Yeah, I think it might be. It's difficult for me to say for sure if the bug is caused by the missing codegen, or if in the codegen we actually not handle that properly. Right, so this is struct field pointer. Do we have anything? Right, and I need to adjust the stack offset here to actually get a proper value out. The pointer is in the register. Right, so we have structure, we want to return the pointer. So we need to add some stuff in. So we're gonna do register manager, freeze reg, not free, freeze that one. Feel free to shout out, Yahim, if I'm doing something wrong with the API, but I think this is how it's meant to work, right? So wait, so we have, what do we have in the register? We actually have pointer to the structure, right? I think. Yeah, we have a pointer to a struct, or a union, or union, yeah, and then we have a field index. We want to return the pointer to the field. Now the question is, do we wanna do we want to return it? Hi Hazy Code. Do we want to return it on, like, as a register, maybe on the stack? I guess it can be just in the register, right? Since we have it in the register, we can just add and subtract, and that's it, I guess. So, right, hopefully my arithmetic is going to be correct. Right, so let's try and allocate wait, what was the, I think it was copy temp register, right? I think we can use that here. Copy to temp register. So we actually, what do we want to do here? I think we want to put all this stuff, struct size, struct field offset, and struct field size, in the register. Yeah. Yeah, correct. Yeah, we can reuse it as well. Yeah. Yeah, I'll add all this stuff in a minute. But basically, we want to put it in the register again. Like all this stuff we want to put in the register, and then we just want to add that to the offset, right? And I think that should be fine. For the actual value, yeah, we want to make this. Is it in it like this? I can never remember this stuff. Oh, in a tag. In a tag. copy to register, and MCV is actually going to be an immediate. Oh, can you? Probably like this. Yeah, thanks Firefox, we'll see if this works out. If it does, then awesome. Actually, let's make this to field. I wonder if I have the arithmetic right, because I think I need to invert it perhaps. We'll see. And then offset. Yes, and as him said, if we can actually reuse. So we want to actually do that anyway. And then use operand instruction. What is it? Wait, I can never work out what that was. Right, where do we go? That's the operand. What's the op index? I think it's 0, isn't it? So if we can reuse the operand, let's make it a bit nicer here. Then we can break with MCV. Otherwise, actually don't need the stuff here. That's fine. We will do one sec, right. First of all, let's freeze that one. Maybe this is not the best way of doing it. Okay. Are you sure? That's a good question, CryptoCode. The answer is no. The way we have it organized, the way we access memory on x86-64 is drastically different to how it's done in ARM. the reason we have an I32 is because the way we actually operate with the stack is slightly different. We always mark, what do we mark? The end of the entire thing, and then we actually go backwards. I can't remember exactly. I always get confused by this. But yeah, I'll need to have a look. But that is different. We even have in x86 we have stack offset as I32 and not D32 because we are allowed to go. We are allowed to actually increment this. Well, go up the stack. No, down the stack. Wait, go down the stack, right? And this is the reason we have I32. We could actually introduce a new MC value for this, but this is specifically so that we can reuse the machinery to access arguments on the stack when they're passed to a function without copying them over. So we then reference, we recover RSP for the caller, and then we start popping the arguments from the stack in reverse order. So, and we basically read directly from that memory there. Does that make sense? Yeah, it kind of doesn't, but then yeah, he might be able to, you know, maybe we could in the future, but I think that stuff, the memory stuff, is drastically different. Like in ARM, as far as I know, everything has to go via register, right, Joachim? There's no such thing as a memory operand as such. So, where was I? Frap. Oh, I wanted to defer. Register manager unfreeze reg. Right, and now if I can reuse, I don't have to do anything. If I have to, then freeze. Right, registers immediate, yeah. Register manager, alloc reg. Yep. Oh. Or let's call it result reg. I'm gonna clean up later on because I think this can be done in a simpler way, but let's just go with it for now. And then if self reuse you know what, wait, operand if we can. In fact, I don't think we need this anymore. This is gonna be pretty clean on it. Oh no, we do. Whoops. And then if can reuse operand, cannot. Self-register register manager unfreeze reg. Oh wait, do we want to unfreeze it? Oh, we just want to, okay, right. thing like this. I'm still getting used to this and freeze. Right, okay, so I think this is roughly okay. I don't know, I mean, we'll see. Genbin. Right. I want an add. The destination is a register. Oh, and I need to still move it. Frap. Pardon me for my chaotic typing here. I forgot to actually set the register that we just allocated. Obviously in the wrong thing, in the wrong place, because why would I do it in the right place? We allocated a new register. Result. Right, 1 second. And then gen set reg. Type. Result reg. Okay, cool. Here is the I think is that the MCB? Yeah, source is offset reg. Break result, we're going all the way. Oh, okay. Register result reg. Okay, I think that should be it. So we actually copy the offset to a field as an immediate into a register. And we copy the pointer to distract. It's a new register if it's not there. If we can reuse it, we just reuse it. And then we add them together and return result reg. I think that's it. I need to stop rebuilding the entire thing. Oh. Wait. I think. And how did I? Oh, skip, not native skip. Is that correct? Is it skip C or something? Oh. Oh, okay. Type inference. Whoa. Yay. Stage 1 bug. Yeah. Believe it or not, I'm actually, yeah, you know, you can get a lot of those. But wait, maybe we can do it. I'm not exactly sure where it's coming from. Let's clean up a little bit. Oh, I know. Let's do it this way. Maybe that's gonna help a little. And then return. Let's see. And it was format again. Yeah, why was there? Oh, shit. Format. Yeah, it's something to do with type inference. It might have been as simple as actually adding empty value to scope dead, like explicitly. Sometimes it happens. Sometimes it's okay to just break the stuff into a couple like more explicit blocks. In stage 2, we won't have this problem. But yeah, anyway, I don't know why I'm rebuilding again. Right. So let's start with something simple first, I guess. You know that's snowing again. I mean, I like winter, but I had enough. I had my share. I wouldn't mind some sun. How is it in Italy? Loris, is it sunny? Is it nice? Is it warm? Right, cast indirect. Okay, that's surprising. I'm kind of scared. 14 degrees, yeah. Screw you, that's what I'm gonna tell you. I'm moving. Yay, segmentation fault. Okay. So that's probably because I'm adding crap, like this value that I'm adding. And this is the main, like, who was asking, hazy code, crypto code? Yeah, crypto code. That's the thing with the way we handle the stack offsets in x86 64 is kind of specific. Because of the fact that we always refer to them in negative, like basically negative offsets. So I think this should be like that, negate. And I think this way, this very much pause. Oh wait, maybe, or is it subtract maybe? I'm pretty sure Joachim's gonna agree with you. Oh, I mean, hell, I agree with you too. I just like pain. I like x86 64 because it's a lot of pain. I love it. Just make incremental work on ARM first. Hey, don't take away my fun. Wait, is it this way? I'm gonna peek. Nobody. Hey, I use x64. Struct field pointer. How did Joachim do it here? Yeah, see? Because this is how it should be. And yeah, maybe I'll try, and I don't know. I need to have a look if this was possible, if it would be possible to actually do this, do the same operation in x64 for stack offsets, and just do some kind of like inversion, like negation, basically, later on. So we subtract here, but there. Oops. And here, I think we should be adding that like this. Yeah. Oh no. Wait, what do we get here? Let me have a look. What was the layout again? Because I don't pointer to struct. We're at the beginning. Maybe we don't even need to add all this stuff. Maybe I'm wrong here. We have yeah. Oh yeah. Oh, if it risks everything. Use PowerPC. Oh, I love this. See, Loris, use PowerPC. Do I even field size, field offset? I wonder. Yeah, I am wondering. Hey, Risby is cool. I actually wanted to get there is yeah, I should fix this later on, but there is what was it called? Damn, I can't remember. Oh, sci-fi, right. Yes, I wanted to get my hands on one of those. What is it? Oh Jesus, there's too much stuff. What is it? Oh, boards. There we go. I think it was that one. Yeah. So I wanted to get my hands on the High Five Unmatched. Rui, who's actually the creator of Mold, he got one. And he said it's fine. It's fine. It's just that it's super slow. And it doesn't really have a lot of RAM as well because everything is integrated as far as I know. Yeah. But it's he said that it's then again he's got a Threadripper he's working on mainly as far as I know. So, you know, for him this one would be super slow. But yeah, he said it was surprisingly slow. Like for example, M1 is a lot faster. It's a lot more optimized. But yeah, I'd love to get my hands on that one. Yep, I think sci-fi. Yeah, I think PowerPC is it's a pretty powerful architecture. I mean, I don't know why Apple actually switched to Intel. Performance? Maybe they didn't want to. I don't know. Maybe they didn't have experience in making their own, I wonder if they had all the experience they have now with ARM, if they would switch in the first place. Maybe just leave it and just stick to PowerPC. Don't know. The Wii U is PowerPC. I didn't know that. Oh, was it Thunderbolt? I don't know. I genuinely have no idea why Apple switched. Yeah, okay. Right, what was that? Okay, right, now let's try this. So let's try plus, and then at the end, and then that would be like this, right? Yes, no, maybe, no, huh? No, is that the same thing again? No, wait a minute. What am I doing here? Oh no, this is the same thing. Oh. Oh, it's the same as an ARM. Fancy that, my mistake. I thought we had the oh, maybe that was running for pointers. I'm confused now. I thought that was calculating the offset slightly differently here. Oh yeah, in that case, easy code. I think this can be redone as U32. I don't see any difference here now. Oh, later on I'll have to do a I32 for pointer stack offset. Right? I think, and then that can be done like this. Yeah, I think so. Yep. Wait a minute. Yeah. And here. Yeah, I think you're right. I think it should be the other way. So subtract here. There is some. I mean, if it doesn't work, we'll just open up the debugger and see what we're getting. Nope. I wonder if this is the const cast or something. No, it shouldn't be, right? Okay. Right, so this is actually an address. Not that one, right? Is it? Maybe. Well, let's have a look. Wait, this is just us preserving the registers. This is fine. Right. So we're moving that into RDI. Uh-oh. What? Wait, am I blind? What? Wait a minute, what the hell? Actually, what is that address? Mm-hmm. That's fine. Why the hell did it not move into the register? What? Mm-hmm. Nice. Wait, what the frap is happening here? What's 37? So wait, is that something that we generate? Did I mess something up here? No, but that's Yahim, that's fine. That still doesn't explain why I'm not loading an immediate. Per cap. What does it mean? Wait. Oh yeah. Wait, this isn't happening here, I don't think. Oh, that's why. Hey guys. So Togglebit is raiding with 138 people. That's brutal. Hello. Hey guys. Hello and welcome, I guess. Yes, Loris said I have work to do. We are watching you, thank you. Yes, so hi, we're basically going through stage 2 compiler. In this case, looking at the x86-64 backend, trying to add peer reviewers, trying to add basically trying to pass a couple more behavior tests. In this case, basically trying to extract, given a pointer to a structure, we're trying to get a pointer to the field. And so yeah, so if you're interested in Zig, Zig is an upcoming systems level programming language, which is very simple, cool to use. So thanks Togglebit. Have a good one. Yeah, so if you want to watch some Zig, please stay. Ask any questions if you have any. I can actually take a break with this, and then I don't know, show you some stuff if you want. If you have any questions, let me know. In the meantime, let's do some more debugging because I have no idea what's happening. Didn't expect to see this in the host. To see what in the host? You mean me, right, Surfcat? Didn't expect to see what? Oh. Zeg, yeah. Yeah, there's only Zeg. And you're... Thank you. Yeah, I think Harry Potter would be a perfect face for Zeg, you know? Given the lightning and all this stuff. I don't know, I'm talking crap. Ignore me. Right, okay, so something is wrong here, and I'm wondering what could that be. So it's not genset reg, because that should be copying register into a register. Let's have a look at object dump. Maybe it's gonna reveal something. What was it called? Endcast. No, wait. Cast indirect. Yeah, there we go. So genset reg. Do we even have subtract or atomer here? It's gonna be main. Oh shit, okay. Right. So we're actually moving the content of the memory directly. Why? Wait, is this, so this has to be something that we've done here. Why isn't this visible though? Selective duplicate. Yeah. My avatar from Twitter. You mean the one that's demonstrating how, how not to use the block ciphers? Basically, my picture being theoretically encrypted, but not really. Because that's what it is, by the way. I don't know if you guys know, but let me show you. That's when I was still playing with this stuff in the past. Oh, you mean that one, right? Probably. So I actually made it with, oh yeah, there we go. I actually called it ECB art. When I was doing some crypto in my spare time, demonstrating why you should never use that. Like use ECB as a block cipher, electronic code book. Yeah, the obfuscated one, yes. Very much so. Okay, right. So, right, good. So let's do some logging then, because I have no idea what's happening here. I'm kind of confused where stuff should be and why it's not where it should be, or what I would expect it to be. Good enough to be shipped by Monday, thanks. Come on, come on, come on. Right, cast indirect again. It's RDI, okay. So that has to be that one then. Where is the sub Yep, sharper guy. Yeah, exactly. So I recreated that with the, basically if you go to my blog, like this is a very old post. I actually recreated that stuff when I was learning about ECB and other cryptographic primitives, and I thought it was hey, that's cool. So I might just, I created the code, replicated that, worked. So I then I fed in my photo, and that's what I got out. So looks nicer than me in real life. So exactly, I look blocky. No, I don't, by the way. I'm just joking. Right. Where is this sub? So we have a move. Why do I have a call here immediately? Like, what the hell? Unless this is happening here. It is happening here. Right, okay. Here is the sub. So the problem is actually here for some reason. Huh. So we're moving the contents of this address. I wonder. This looks a little bit wrong. Why are we actually doing a dereference? Oh yes, just a test. 3 counts pointers in a row, basically. So this is in fact, maybe I wonder if this is the problem here. No, it shouldn't be. Okay, so we're actually triggering that one here to move the contents of memory address with respect to a segment. I think raw data in this case. Yeah. Well, I'm deep. I'm at the back end of the compiler, I guess. That's the posy, you know. So that right. Okay. So let me, for guys who just joined in, let me show you again what's up. So we're basically trying to get this assert to pass. So what we have we create a struct on the stack with x being 42. We take the address of the structure, we take the address of, we take the pointer to a struct, we take the pointer to a struct, we do a const cast, and we should basically be able to return the value of x. And it should be equal to 42. But what we actually get, surprisingly, is wrong. We get a seg fault, because we're accessing, we are dereferencing a memory from the elf binary directly, and it turns out to be a 0. And I think what we should be doing, we should be just moving in the value of that memory that actually dereferencing it. Yeah, but this actually, you know, this used to work. Like this actually works, the referencing and stuff. In this case, I don't know why we're actually generating the wrong MIR, like middle level IR instruction, before lowering it to x64 machine code. So let me break in main. And the problem is, so we have our prologue. Thanks, Hasty Code. We have our prologue standard stuff. Then we actually save any call saved registers on the stack to then pop them back out. And the problem is here. And this mob abstraction, I'm not sure if you guys are happy with AT&T syntax. But anyway, yeah, we do that here. And then if we inspect the memory, even do it like this, whatever. That address. I think it's beautiful. It's all zeros. So, and I think instead we should just save it instead of dereference it, because if we go in and we inspect the registers, we obviously say we just moved the dereferenced value of that address into RDI, which is 0, and then we step in. We actually call const, and p is 0 because that's the value of that's the dereferenced address. I don't know why do we dereference stuff. So there is something wrong. I don't think we should be doing this. And where are we doing this? That looks like an argument to a function. I think I must have messed something up here. Wait, register, stack offset. That's the register, that's not. So yeah, so the trick now is to exactly work out where it's happening, and I can't remember exactly. I think it has to be something with not following the basically a mistake in how we pack. How we treat a pointer. Instead of treating a pointer, we actually treat we say we want the value behind the address, which is wrong. Not saving on the stack now. Oh, this is passing register. That's okay. We just save it here, so that's not gonna be here. So I think it has to be here. So this should be pointing to our RDI actually. Oh, I might as well do this. What is the type of the argument? Where is it stored right now? Oh yeah, it is gonna be this. And I bet it's gonna be memory. An argument type is wrong, probably. Or maybe it's not wrong. Maybe we have to have a switch. What if it's a pointer? What if it's just a call E? Oh. Okay, so I bet you that argty is going to be a pointer. argmcv is going to be memory. Then we go in and to genset reg memory. We go in here. It's not a pi. We skip this crap. We end up here and we dereference, which is wrong because actually we should be doing it like this here. But we don't need to load effective address, do we? No, we just need to just basically move it. So I bet you that something like this is what we need here. Do we need to save it here too? I think I should do it here. If is a pointer. Maybe it was capital. Generic Python. Opaque. Bool void fn function vector pointer. So basically, if it is a pointer, we should simply do this. Move it. Red one. We register flags will actually be 0, so I can probably skip them. I need to encode this. And then data is an immediate. What do I pass it as? U32, cool. We don't have to worry about x being actually larger than U32 because it's an address. Or can it be? No, it can't. And well, actually no. Wait. And it gen said reg. What if it's too big? I should take it out of this too. That's crap. What am I doing? Oh, I don't like it. Right, I'll fix it later. This should be made into a common thing. Yeah. Do we have ABI size here anyway? Yes, we do. But if it's a pointer, it has to be... No, wait. Yeah, if it's larger than... I think, okay. Before we rebuild this here. Yeah, RDI, usize, const. Oh, it's a usize. Oh, but immediate 0. Right, that's memory, yay! Okay, it's even a pointer to a pointer, whatever. Yeah, see, we dereferenced that. Boom. Wrong. I did not see that coming. Ugh. Oh. Let's see. Oh, and then, I don't know if Yahim is still here. Are you here? I think he might be. Anyway, if you're here, yeah, afterwards we can actually have a look if the offset to the field is working or not. I think in this case it might be a bit difficult to test because I think it always is 0. But we can tweak the structure and add some dummy field or something. And move that one down so that we can test the offset stuff. Okay, cool. Right, okay, so this time, hopefully, we're actually not dereferencing the address. So we're storing the value of the address so that we can dereference that later. Let's have a look. Object dump. Yay! Uh-oh. Oh, frap. Whoops, I forgot to return. Okay, yeah, we'll see, we'll see. So wait, give me 1 sec, okay? Wait, where is it? Here. My bad. That should actually be a return for now, like this. Oh no, but then we don't actually want to return the index. Right, oh my god, I'll need to clean up. Yeah, so let's just get this stuff working first, and then we can then tweak. Oh, that's ARM. There we go. We can then tweak this stuff here. So we have a plus for stack offset. Yeah, here. Where is it? There we go. Yeah, we can swap the sub into for an add if the other one doesn't work. So we'll see. I think you're right. I think it has to be an add. Okay. Object dump it again. Oh. Yeah, okay. Yeah, okay, no dereferencing in or anything like this. Okay, good. Right. Oh, actually we can run it. I think, yeah. So I think you're right, Yahim. I think this should be add like it was before. So now we're trying to, for everybody watching, now we're trying to, so we actually, we get the right value stored in the register when we're passing that to a function, which is a pointer. So now effectively it's just trying to get the, so having the pointer to a struct, we want a pointer to a field. And we were debating whether it should be some like an addition, basically having the pointer to a struct plus all the information about the structure layout, whether we should add that in or subtract it. We both, like Joachim is actually, by the way, he's going to be streaming in today at, I think 5 p.m. is it? Central European time. And he's going to be streaming his work on the ARM backend. So you should definitely have a look. You should definitely subscribe to Joachim. Right, let's have a look. This is still fine, and then we have const. We actually do an add. And the funny thing is, the immediate must be 0 because we XOR it. Let's see, and then const. Where are we now? Okay, just after the prologue. Okay. RDA should be yeah, 0, yep. Yeah, it's the address in the RDI, woo! Oh my god. Okay, call the function. Then, yes. With. Oh, it's a void. Oh, it's a 0, fuck. Yeah, but this is, thanks. This is just getting the pointer in. I'm not even sure that it's correct yet. Oh well, yeah, thanks. Because, you know, obviously this is, yeah. Yeah, I wonder. You know, I think it was right though, because this looks awfully like this address, like that range looks awfully like a global offset table, and we should actually store a pointer within it that would point us to the actual structure. So I'm wondering if this is messed up. If I'm basically what I did, I didn't actually fix anything. I made it worse. Well, let's see. Save. Yeah, okay, yeah, see? Because we dereference and save it in RDI directly. Boom. And then RDI is 0. And that should be the pointer to, that should be the value of X. So we should be able, like a pointer, so we should be able to just dereference that here. But obviously if we continue, it's a seg fault. And rightly so. Okay, so it wasn't this. So this most likely is not needed. So why, oh why, are we not actually populating the God properly? Wait. That was the symbol table. Huh. So here's the thing. I wonder, because it's not in the symbol table. At least I don't see any S for a structure name. I would expect it here to be. We have arrow data. It has some size. Like how did I print the contents? Wait, the section details. No, I want just the section. What is this? Is it X? Yeah, okay, we can do with an X. Number. Or just maybe name, arrow data, number 4. Ah. Cast indirect. Okay. Wait, that looks like poison. What about God? What is it? And it was the address. Which one was it? $60. This is 0. Shit. Oh, maybe. No, wait. We don't have BSS. That's not a global. Okay, so something is clearly wrong here. I don't know actually where. Yeah, so this is definitely not needed. It was actually correct all along. Is this something here? Are we actually not saving it properly? Hey, wait, I have a, we can do a test. I wonder if this is actually going to change anything. Cast direct and then rebuild, because That was wrong all along. If anybody's got any ideas, please shout. We might have to have a look in the linker. I think the linker is not properly saving it. Or worse, maybe choosing as a const and it's not actually doing anything. The stuff is hard. No, it's not. Come on. Come on, Firefox. It's not hard. It's just a couple of addresses here and there and that's it. Wait, graphics is hard, by the way. I have immense admiration for people who actually do graphics. Or operating systems. It's insane. Right. Let's have a look. Oh, okay, so this actually doesn't matter. Okay, so good. So Zig is pulling this out from the function into global scope. Or is it? Is this Rast? No, it's Zig. King of Delphi, this is Zig. So whoops. Yeah. That one looks fine. I think it's 80 actually. Oh no, it's, was it? Wait, so if I did 80, then if we keep going, maybe 70. But then that's yeah, but it does look closer, but I'm not sure whether this is correct though. Something I think is wrong on the, so the linker doesn't save it in God for some reason. So wait, but let's have a look anyway. So and 42, what is this? That's not it. What about here? Ah, right. Hey guys, please don't fight over Rust or Zig. Both languages are cool. I really like Rust too. Const. Oh, found it! I think so, or maybe not. No, wait, that's a function, isn't it? Is this a function? Is that it? What about 60 was actually empty. And there's that one too. That one is 8000 ED. Whoops. That's an assert. Right, okay, this is silly. Let's have a look what the hell is happening. Update deco. How should it even work? Like the structure should be saved on the stack, right? So why the heck am I supposed to look in the God? Oh, we have a... we're trying basically to get this to work. Having some definition of a structure, we create it on the stack. We take an address of it and then an address of the pointer to it, and then we want to be able to call this function on the structure to get the value of the field out. But for some reason, we're actually passing in the wrong address into a register, which then would actually hold address of 0. So obviously, we're trying to access something we shouldn't. And I'm trying to figure out why. Yeah, correct. King of Delphi, yes. We're taking the address, yep, and then this actually resolves into an address, a cell in the GOT table for some weird reason. I'm not sure why. It might be right, but the cell in the GOT is actually unpopulated. It's full of zeros, so that's also wrong, right? Even if something was meant to be there, it's not. Oh my god, where is this? Make string flash module. Deco block list. Oh, that's for the arrow details, fine. Right symbol. Where is right color entry or music? Maybe it was global table entry or something. Video. Oh my god. Or offset. Yeah. Yeah, okay, let's have a look. Okay, so what we have here? Linglipsy now object format OS. Zig backend output mode. Linglipsy object format. Main exit main. Right, we do allocate for const, but this is a function into struct. Um, yeah, but I don't think you get the point. No, the point is, I'm trying to lower that into actual machine code, and the lowered machine code is getting the wrong address for the pointer to a pointer. So the thing is, the problem is not in actual. The problem is not in Zig. The problem is in how we lower that into machine code. That's the problem. And also how we link it. Thanks, CryptoCode. Yeah, I still don't understand why we are pulling a address in the God table. And even if we are, what happens somewhere here? Not here. Air call. Wait. Okay. But this is a function call. Which is fine because we actually call the function correctly, but we call it with the wrong argument, which is 0. Which is 0. Do we actually access... Do we access got in anywhere else? I don't think so. Yeah, we do. Okay. Oh, actually, I am Dusty Posy. I am at this level, right? Oh, C is the greatest of them all. Yeah, mine is the UB, I guess. Right, so it has to be happening here. Lower. I think the problem might be here, actually. I think it's here. Wild guess. Well, another point I would like to make, if nobody ever designs a new language ever again, if the old guard basically goes away, who's going to maintain the old languages like compilers and stuff? Because bugs are obvious to happen, right? So somebody needs to be able to do this. Well, yeah, Fortran is used, Ada is used, but you know, Every other language is used. It doesn't mean we should just basically stop. Hey, Lucas. Yay, it's that stuff. Yeah, COBOL is great. Okay, so we are here, and then we go into lower decal ref. On COBOL or Zig? How cold is it? It's snowing, Lucas. Let me tell you exactly though. It's 0. It's not too bad. Okay, so this gets offset table index. That means we did call allocate decal indexes. Thank you, Hazy Code. I mean, I don't know about you guys, but I'm working on a compiler. Yeah, is pretty exciting. Gives you the thrills. In the beginning, it was difficult reading the assembly code, but it's not even a problem anymore. Now it's more actually getting everything wired up together properly. So this is clearly some kind of a bug in, I think, the linker or the loading code in the codegen, because we're getting the the address of a gut cell that's not right. Right, so we did call this, and then wait, it was the decal ref. And then we have 2 entry points there. It's either update flunk or decal. That's true. It's not even about registers themselves. It's about getting everything properly wired and actually getting all the instructions speak together, right? And then we get into more complicated stuff like FAT, our SIMD support and things like this. Yeah, we actually we got that covered, passing arguments to functions pretty well. We even have so in Zig we have incremental linking, like in place binary patching, I guess. Actually, Andrew demonstrated that it can be used to hot code reload. And we get even properly updated dwarf info for functions when you move code around and you recompile any bits. The line numbers are properly updated when you do incremental linking. So it's pretty cool. Right. So this has to be somewhere here, I think. Yeah, by the way, I'm gonna make a stream soon when I get back to actually working more on the elf linker, because I think Mako is pretty stable right now. I'm just missing that code stripping plus a bit more for incremental linking on macOS. But I definitely need to pull to go back to elf and actually start upstreaming that here, so that we have more complete support for elf linking. Yeah, haven't we all, King of Delphi? Okay, this is writing the new one. I don't want to write the new one. Okay, so I should be able to see this, and the name should be indirect S. Call main, exit 2, start const, no. Huh. So it doesn't get to this stage. Interesting. I wonder if it's, I wonder if it's treated as a const. Does it ever get there? Okay, we have the bug info for this. To do. Hi edu, and I'm not even gonna pretend I'm gonna read all those digits with an E in the middle. Okay, so there is update deco being called. Right. Wait, where am I printing the debug stuff? Oh, it's probably in link. Right. So we do call it here. How many developers use Zig on average? I have no idea. Loris, can you shed some light on this? Loris is our guru of outreach, so he should know better, I guess. It's definitely getting more popular from all the messages in social media that we see, right? So, wait, can it? Is that it? Can't be that. That would be completely broken. Yeah, I think it's the variable here, that's fine. And then we do generate symbol, but why would we escape prematurely here? Chief of outrage. Yup. Even if we go here, I don't see any. Oh, unless we're going directly here. So wait, but why would that even happen? Uh-oh. Right, so it's not that one. Good. Perfect. Okay, that means it's fine. So we enter here, and we probably enter here. What the hell? Why would we? Let's add some more proposed debugging here. I missed my debug logs from Mako, to be honest. Was it mem span 2 or something? Oh, slice 2. Yeah, Tiger Beetle is cool. Right, okay, where are we? So update, let's see, update the cool code. Always decal, start to decal, const main, exit, assert, const decal, native OS decal, stage 2. What the frap? Okay, so we actually don't enter there at all. I think we have. I think Zig is actually, as Loris pointed out, Zig is growing pretty well itself. Like, and we do, we do whatever we can, but we don't have any. We're not like Rust, who had Mozilla as it's basically like a founding company, I guess you could say. Anyway, suffices to say, I spend a big amount of time coding in Rust, and I'm way more productive in Zig. So, but obviously, sticks and stones, right? Apples and oranges. Rust is far more safety oriented and in a different way with its borrow checker and things like that. So right, we don't enter here. That is shocking. Now this is something I did not expect at all. Oh, I bet you this. No, wait, no. How did right, I think I need, no, can I break on this? Right, let me check again. Oh, I love those. Yeah, Firefox. Welcome back. Hi, Dave Obi. So Firefox, is this a linker error? I am not sure. This is an error, and it might be a deficiency in the linker. Like ELF is far less advanced than Mako. This could potentially work on Mako, but I'm not gonna switch midstream to a different computer. That's crazy. Could I though? No. Yeah, this is weird. Like, it's basically what I'm looking for. So the address, like I'm looking for the address, like basically a pointer to custom direct.s, and then the structure should be defined somewhere, but it's missing. Like, we don't actually populate the offset table entry for some reason. That's why 0, because we say we will, but we never do. Right. Where were we? So okay, so the other option, like, is this some kind of a silent error? Could that be it? Or is that something connected to this line? So we definitely call update the colon main anon 4. And then what is decal vol then? Let's insert that too, why not? Oh, for the record, Dusty Posy, I actually did that with Haskell. I learned Haskell with not really following the documentation very much. The biggest problem for me with Haskell was not actually the language itself, in the sense that lack of docs or no, I'm not special. Come on. The problem was the paradigm. Like, functional programming was totally different to imperative, and that's I think that's the killer. That's the wall, right? You have to get over. Like, how do you compose stuff in a functional setting? Cast indirect. It took me a while to actually get relatively comfortable with Rust. I think Rust's type system and, because it's got the borrow checker and the general architecture of the language, makes it pretty difficult. Like you have to rethink how you think about problems. That was my experience. Enum field. Okay, in both cases, what? Wait, what? Okay, it's a decal ref. And no checkpoint. Right, a black hole. This is a black hole. So this has to be, is that it? Cogent failure, is it? I think this might be it. Oh my god, oh yeah? Is C# blank ref like so bad? Oh, by the way, when it comes to docs on Zig, we're working, like actually a lot of this is spearheading the stuff for the auto docs. And we will have them. The only thing is that the language is still not stable enough to actually spend, we don't want to we want to minimize the costs. And we don't have that many people actually working on it full time, so we need to pick our battles carefully. I'm gonna turn on some lights, maybe it's gonna be better. Oh no, here. Whoops. Maybe a bit too much. Right, anyway. So this is fascinating. I'm sorry that during the stream you had to endure this. I thought we were actually going to focus on codegen, but we're actually well, in part we are. But mostly focusing on like what the heck is going on at the boundary between linker and the codegen. So, do I have any? Oh no, no, it's not. Oh shit, this is right. This is fascinating. Any bug by creating, yeah, true. But now explain to me why the hell, unless this is failing, is that failing? I wonder. Yeah, I think this is a wake-up call for me that I should spend more time on the linker now. And I've been putting it off for a while. So Yay! Found it. Whoops. So the good news, we found it. The bad news is generate symbol is tripping up. With an error, which should never happen. Which should never happen. Should not, should it? Wait, it's on left. And it's actually here. Okay. Mystery, mystery, mystery. Right, let's have a look now. Oh no. Custom direct, build again. And log. Analysis failed. Shit. I wish Andrew was awake. I think that this is slightly above my pay grade, so to speak. Why do we mark it as, so why is it not complete here? Okay, do we have a point of reference? Did we? Wait, no. Oh, is that only because we actually don't generate the pointer to distract? Wait, we do the relocation here. It's fine. Now this is getting the address. Okay. We probably shouldn't do that. Yeah, so one of the focus, like our focus in stage 2 is on speed of compilation plus linking to. Even using LVM as the backend should be faster with stage 2. Obviously, with native backends, we should be even faster because we want, for the back builds, we will not be doing any optimizations because, we don't actually need them for the back builds. Just rinse and repeat. Unless, I guess happy to be proven wrong. Maybe for game industry, you need some performance in the back too. Or maybe release with the back info, I don't know. Well, I mean, you don't want to have, you won't really have a choice because I don't think we're gonna manage to have both linker and codegen done by the time we want to release the first iteration of stage 2. Since you people, what? Hey, Loris, let's make a deal. You get me a beefy ARM that's gonna make my Linux laptop run like the M1 or the MacBook. I'm game. I can switch to basically developing ARM 64 for you. Yeah, look at this. Okay, so I think the culprit here. Is that stuff, but I don't think we should have error analysis fail. Right, I get a hazy code. Yeah, okay. Yeah, so this is something we'll need to revisit. With Zig, because we want to have scoped optimization, I guess, you'll be able to annotate if you want the function to be optimized or not. And you'll be able to mix and match. Maybe that will be a solution to the problem with game dev. Like you will have, the hot paths you can mark as like optimize away. And then anything else you can just leave as it is. Yeah, 10 times or 100 times slower. Yeah, I'm not sure. Like, I don't think we have real numbers, or we won't have real numbers for a while still. But I don't know. I mean, I think in the beginning it might be it might be slow. I don't know. I mean, the runtime. We'll see. Because we literally don't do any optimization passes yet. Even in the linker, we are very liberal with the use of the global offset table, and that's not good for performance. God indirection is the worst. It's the first thing that the linker optimizes out if it can. But without this, incremental linking is kind of difficult, if not impossible. So we'll see. Yeah, basically, we need to have a look. Like, I think the moment we have stage 2 with either of the backends, like native backends, we can start actually looking at performance implications. See, what's up, what's missing, where we can make things a little bit faster, and things like this. So right, anyway, so here's the thing. Lower decal ref. What is it actually? Let me. I feel like we should have an if prong stating that this is still missing. Yeah, I think what Remus is saying basically just after OP, just functional language and a system language. Yeah, if you want front end, then JS and TS are cool. Right, let me print the type. I have no idea what that is, and it's definitely some kind of a pointer, but okay, so this is fine here. And I guess there is an error like this because this is a SEMA failure, not a codegen failure. Okay, fair enough. Well, it's a nasty thing. Maybe we should somehow flag it up. Oh. Huh? Oh. You're kidding me, right? Oh, shoot. Forgot to enable the debug log here. Okay, that's not very helpful, I guess. Oh wait, we could check for a slice. We could and then return a fail. Sweet. Yeah, I dislike Python too. For me, it's too messy. Yes, thank you, dear Kupkonia. I'm actually not really working on the compiler backend. I'm trying to figure out where the hell it's failing. Oh, I don't need that. Yeah, true. You have to believe. Yay! You have to believe that the test will pass to pass the test. That's very deep. Sebastian, I don't know how to respond to this. Right. Okay. Ah, crap. I'm sorry when you say about friends test. That sounds like C++ to me. Okay, so this was the problem here. Okay, so this needs to be implemented now for a structure. Out of curiosity, let's have a look. So we have, is there like a struct field? Oh, what's this? Maybe that's it. Yo, oh my god, friend classes are horrible. In general, I like C++ is fine as a language. The problem with C++ that I have is I think Loris mentioned the grepability test. I think it was Loris who mentioned that. Or maybe it was Andrew, I can't remember. But basically, if you look at any code base in C++ and then trying to work out without running the code, but just reading it and then doing selective searches like greps, it's freaking hard. And I think the same as in Rust because of all of the you can actually implement the trait for any type. Effectively means that you can actually extend. Well, I can't read my codes too, but that's a different thing. But just grepping through it. And you can find stuff, and this is a cool thing about Zig that you in general you can do that. There are some places you can't, since we're using a lot of data-oriented design for building the stage 2, and I kind of fancy it too because we actually work on the encoded and compressed data all the time. It's difficult to grep for stuff too. It might be kind of difficult unless you have good. This is where really good docs come in, like in the code. When we deal with DoD, I think. But in C++ it's always the case. That's my experience at least, and Rust as well. Like for example, I cannot read my own Rust code anymore. I even had a problem with this. Like a couple of weeks after I wrote it, I was like, "Whoa, what is this?" And I was abusing proc macro like a lot. But yeah, whatever people like, to be honest. Oh, this is just a pointer type. I know, right? It's like, yeah, reading it is really, really straightforward. I know. I totally agree. Right, so wait, what do we do here? Oh, so we generate a pointer. Ah, right, okay, so for the structure, I guess we will have to generate every single field recursively. So here, and then we could do child. I think the same will apply to union, but I'm gonna do it. I'm gonna be a bit safer here. something like that. Then let's just copy that over with a different message and see if huh. Okay, why? Oh, do I have to switch on the tag probably? Call this element type actually. No, child type. Type value, child type. It's I think we have to switch on the tag. Oh no, it's never too late. I actually started when I was young, but I know a lot of people who haven't. Yeah, so child type actually is not. It's a union enum, I think, actually. But I think. Oh, it's a type, right? But we need to switch on the tag itself, Laris. So that's what I did right now. We actually switch on the tag. By the way, this entire switch prong, the switch expression might be cleaned up. Oh, did it? Maybe. Yes, you're right. It was untagged. Yep, untagged. Yep. But that's okay. We should probably use it this way anyway. So. Yeah, excellent. So we had lower decl ref function for pointer to struct. So the next thing would be to iterate over all the fields, I think. Yeah, tag is a function. Yeah, correct. So wait, I need to help myself here because I don't remember the API exactly. So we have struct fields. Is that an iterator? It is, I think, right? Yeah. So you guys have to bear with me here because this is the first time I'm touching this code. And I'm not sure whether I have to increment anything at all, like any offset. Ooh, I need to pass in the value. What the hell is a value? Yeah, so the great thing working on a code base like this is that you thought you've seen it all, and yeah, of course you haven't. And it's amazing. Oh, type value, okay. You just discover like a single function within a file that you know you most modified that you haven't touched yet, and you're like, oh right, okay, this is where it goes. Type value this. Okay, value. Okay, so yeah, I think. Yeah, yeah, reader exactly. Like actually, I spent the last week going over AST and AST gen, trying to figure out an error we had with source lines, how we increment this stuff, and geez, it was tough. Like it's a pretty complicated code base. But yeah, in the end, it turns out there was an error in AST how we tracked the lines. We were actually not tracking them properly, so this is now fixed and everything is working great. So yeah, learning. Yeah, I know, Loris. Yeah, you started learning about ZIR. Yeah, my favorite ZIR. Okay, so for each one of those, I think I need to recursively do that. So if this is a struct, I should generate. Do we generate symbol for each one? I think, do we? Hmm. So so this is super cool for me personally, working on this side of the compiler, because so I wrote the linker and I know what it's like to actually rearrange the symbols and allocate them in memory. And then here I'm now the one who's feeding the stuff to the linker. So I see the thing from both sides, and the results are surprising sometimes, because you think you know it, and right now I'm not sure what the correct thing should be here. Yeah, exactly. I'm completely like, what the hell? Because I don't, I don't know what precisely what to generate so that the linker is. Thanks. Yeah. Actually, it kind of is, I guess, the x86. In the sense that I'm maintaining it, but if anybody wants to contribute, then feel free by all means. It's gonna be really helpful to get things going even faster. That would be awesome in terms of like feature and completeness. Right. So it field. Now we need to work out here. I think appended is going to be more than enough. Okay, and then right, what the hell is this? Struct fields. Module struct fields, cool. What? String array hash map unmanaged, okay. So here we need a type. And what's a field again? A field has got a type. Oh, wait, are we iterating over? Shit, I'm not sure. Could use that instead. For example. Oh yeah, forgetting what your baby wants and how it works. Sounds a bit too familiar. Yeah. Actually, I have a baby at home, so I know it from real life too. Something tells me I need an offset, but do I need to? I don't know. I don't think we call it anywhere in the linker. We should probably pad it out somehow. Yeah, too much in the compiler. No, she's old enough. She's 3 now, so you know, she tells you exactly what she wants. Well, mostly. Can baby crash? Yeah. Oh yeah. Can well, yes, it definitely can. And here we pass in. Okay, so the field should have all this stuff. Fact, normal alignment. Oh my god, the conversation having changed quite a bit. Oh yeah. So how do we wait? There's an offset. Do we need to use the offset at all? What do we actually iterate over? Struct fields, probably names. Well, let's see. Field type. I'm not sure what value to pick. ABI align or default val. I don't know what that means. Just do it this way. Type is slice. Maybe. I have no idea if that's gonna work. Oh, so arc.rs. You're confused about a syntax. Where? Like, is there anything in particular that confuses you, or what? Oh, okay, gotcha. Okay, right. Is that a struct fields? Everywhere. No, so we use a star to actually get the value out of a pointer. So that's dereferencing. Oh. Where do you see this? Well, yeah, referencing, yeah, taking the address. Here goes nothing. I've got no idea if this is what it expects. Yeah, so the default tuple constructor is confusing in the beginning, but after a while, it's like second nature, and it's super cool to use it. I agree that the types sometimes can get a bit clunky, especially if you have a what is it? How did you do the Borg send? Was it? Wait, I want to be like all fancy. Then Borg. Yeah. Yeah, like things like this can get confusing, right? Or having a pointer, multi-pointer, like this or something. But it takes a like. I'm not sure whether we're gonna change it. That's something that Martin and Andrew will have to think about, I guess. It gets a bit time to get used to, but I think it's in general like once you get a hang of it, it's fine. Ugh, it wasn't it. Okay, perfect. Right, so we actually trying to lower. What was this? Oh, you wait. Excellent, because it is a wait. But the value is all wrong. So is that the default one? I don't know. Oh my god, I'm like. Maybe I'm even in the wrong place. Maybe I should like fetch it from the value itself or something. Payload struct. Yeah, there we go. So, okay. Right. I'm gonna be nasty and let's print. So basically, if I do type value val, what is this? Is this some? Is this a pointer? It shouldn't be a pointer, right? Pointer should be just a thing that is like an annotation for the type. The thing with the Sentinel, that's really useful. And it's super explicit, which I love actually. Okay, so it's a decl ref. Wait, how did we extract the stuff from here actually? Because it has to be a value. How do I get it? How do I get this out? So we need to, basically what's happening here, if you guys still following, basically we want, wait, maybe I'm looking for the wrong thing. What's this function doing? Oh, it's equal. I want to get this stuff out. This is hashing, no. Decl alive, a field value, whoa. Oh, fancy that. You can use a field value, sweet. Okay. And wait, okay, and I think I read somewhere that the fields are in declaration order, which is fine. So if we do this, yeah, I'm gonna totally ignore the alignment and stuff for now. I don't even know how to handle this stuff. How to pass it the linker. Oh. So typed value val field value, and this should be how come we need an allocator here? Okay. Fine. We have been, where is it? Type value, val, field value. Do we have a self here? How do we reference ourselves? Self? Oh no, it's just a function without self at all. So we need ben file allocator. Ah, not here. Goddamn. Allocator and then index I. Do we have a D in it? We do not. Ah! No, no hash. I just want the init. We might not have it. That's a shame. Unless it's expecting an arena. Oh well, okay. Oh, I missed a lot. Oh my god, what is it about now? Oh, food, is it? Yeah. I didn't miss anything, to be honest, thank you. Yeah, I think I'm onto something here. Basically, it's uncharted territory for me because I haven't seen this code yet. Well, I haven't used this code yet, so. So what's it gonna be now? Panic? I think it's gonna be a panic again. Yay! Oh, interesting. So it's a decl ref. How did we get it out from here then? Type by the vowel. Hmm. Oh. Payload deco. Oh, maybe it's no. Is it no? Because this is not. Is it like a child? Hmm. Okay, let's see in sim. Look. Mm-hmm. Right. Oh, pointed echo. Oh, I think it's this one. Wait, why do I point out? Oh my god, no. I think this is it. Element value index 0. Oh, but this is array. Shit. Okay, let's try this for now. I think this should be part of field value, to be honest. I do like a recursive thing, but what's the question mark? Oh, that's an optional type. So optional type is so basically any type annotated with a question mark in front means that it's an optional. So it can be a value or a null if it's not being populated. And then for errors, it's just an exclamation mark. So you can have exclamation and then a question mark and the type. So that means that you first of all return a result, like in Rust, then an option, and then you can unpack it to get the value out. And if you want like a unwrap, I don't know if you know Rust very much here, but in Rust that's unwrap, and unwrapping the optional is basically dot question mark. If the value has not been set and it's actually null, it's going to panic. So it's going to trap at runtime. So this should be, I think it's that one. Where do you see type file? I know, right? It's pretty cool syntax for optional. It's I think it's cleaner than having option and then angular brackets, like in Rust. The zig has an no, we don't have a null per se. This is a semantic. I think maybe we do. I can't remember. I think we do it at runtime. Sorry, I'm gonna type. Yeah, optional box. Wait. What happened? Oh shit! It's a decal. Jesus. Ugh, not this. Uh-huh. So decal ref data gives you a decal. But then if it's a decal, does decal have a value? It does. No clue if it's been populated yet or not, but we'll see. The hard way. That's a decal. No, there's no implicit return. It gets a bit... you have to get used to the fact that you have to put a return, or we have like we have labeled blocks, so you can annotate a block, and you can actually break with a label. So this is kind of useful, but there's no implicit return, so you always have to say break colon block and then the value. Nah, still doesn't work. So the analysis has not been completed yet. So maybe that was fine here. Probably was fine. Okay, so this is not needed here, huh? So the analysis is not complete. Why not? Okay, this is interesting. Yeah, to be honest, explicit is cool. Like, I don't mind it. At least it's clear that, you know, that's gonna return into the, I don't know, from a function or break into the labeled block. So it's easy to follow at least. Oh, you mean Rust does it with option and result, right? Yeah. Dear, oh dear, oh dear. Oops, did I not rebuild it? Whoa, huh? Invalid enum value, what? So C# has 3 ways of doing optionals. What? Like what? So what is like null, optional, I guess, and what was the third one? By the way, Yahim, are you gonna start streaming soon? Gonna make a drop to your stream, I guess, and take a break, and then come back and watch your stream. Invalid. Oh, in 1 hour. Ah, shit. Yeah. Invalid enum value. What the hell? Why? What is this? So Yahim, you have no idea, do you, about this analysis enum here? Shallow analysis status. Oh, it's probably undefined, isn't it? Yeah, this is. So I don't know if you were you following Yahim? So basically we get I think this applies to ARM too. We get a silent failure here. For some reason. But I thought that whenever we access undefined, regardless of what the op is, we will always panic and we compare it to complete. We just return the error analysis fail. I don't get it. This is weird. I wonder if this is maybe a bug in Sema somewhere. Right, and we are in debug. Like I didn't build I didn't build stage 2 as in release mode, so it is in debug, so it should trip. So I don't get why I get a panic with unknown value. I didn't even know how to like unpack it then. Did I modify anything here? No. Let's do a warn, right? Maybe I should just break here. Yeah, it's gonna be better. Codegen 5.1. Oh, yay. What the hell? $170, that's like junk. Yeah, okay, so this must be a bug in Sema somewhere. The hell is 170? That looks like junk. What, do you like free memory while doing something? Oh, is it? Are you sure it's... Oh, it's actually... I thought it was 251 for AA. No? Or 250 or 252. Right, okay. So yeah, it's undefined. So the entire decal struct is undefined, I think. Mm-hmm. Decal is undefined, decal is undefined, decal is undefined. It looks like we actually freed it somewhere. Well, actually, the zip compiler works. It's just that this is something, you know. Obviously, this is a new bug we haven't discovered yet. So, and it works. It must work in WASM because I think WASM is passing those tests. But WASM is not taking this route via codegen.zig. So, yeah, I'm wondering there has to be somewhere. That the decal was freed before it was meant to be, for some reason. I don't know why. I can't recall if we actually, because it looks like basically what it looks like is like you call destroy on module decal and then you destroy it and then you assign belongs to you. Thank you. And then you assign undefined to the value. I think. What's this? Oh, no. Module. Const decal. Oh, we have the backlogs. Nice. It might not be that bad. What are we? What's the scope module? Ugh. Whatever. I forgot to get at this. Yeah, but so true. Rust cost like that would be a compiler error in Rust. Yep. The thing though is, it shouldn't be freed. So there is some kind of a logic mismatch here, because well, the decal exists. I don't know why it's getting. I wonder if that one. But I think it's not. I think it's that one though, actually. Main anon 4. Shadow, as in like shadow variable. No, it's illegal. The log. Like, oh. Right, bear with me. Yes, update equals is that one. Okay, so it's not getting destroyed. That's boring. Yeah, that's true. The borrow checker cannot check that your program. That's what it's supposed to. Well, yeah, you know, obviously. Oh no, we prevented use after free here as well. The problem is with enum. It turns out that actually enum, we can compare. I think that the problem here. Let me explain. I think this is not needed. This is actually already done. I think the problem here is that, wait, where am I? Oh, here. This should be a trap, a runtime panic. Accessing decal.analysis if analysis is undefined should be a trap, I think. But then again, you can actually assign a that value to an enum, so how can you know? So maybe accessing anything on the decal should be. Anyhow. So in this case, it might not be used after free. In this case, it might be that it wasn't initialized. It was left undefined somewhere. Somewhere we'll create a new decal. Yeah. Oh, I really like Rust as well, and hate at the same time too, for its like complexity, I guess. At the same time, it did really stretch my mind. Like, it showed me that you can approach a problem in a different way that's actually going to be safe or tailored to what Rust requires, I guess. Yeah. Oh yeah, yeah. Rust over C++ and AD, sure. Yeah, exactly. Yeah, forces you to think twice about all habits. Yeah, especially the ones that you picked from C++. Right. So in that case, let's. I had simple. What is an? I wonder. Why not? I wonder if this will work. Foo. Oh yeah, RR. Yeah, I think Andrew mentioned that. I should try it. I don't know how to actually use it, to be honest. But I need to know which memory location, right? Yeah, I'll need to read a bit more about RR, unless you guys have some pointers how to use it. Okay. Oh, wait, what? Okay, so I think I can just basically install it and then. Yeah, so give me a sec. Let's. I want to see because this is surprising. I think this is to do with that. I think. Or not. How the the hell does this work and the other one doesn't? Sorry, what? Huh. Oh, right, shit. Of course. Okay, so it still tells me to implement the type. And yet it works there. Oh, because it's const. Check it out. Yeah. So just make this, I guess, full. No. Okay, so this is something to do with lowering double pointer. One, two. Is it? Mm-hmm. Ah, fancy that. But it might still not be working very well. Huh. Let's do it this way. Yikes. Oh, so this is the problem we had before. Register allocation. Thanks, Arcadots. Bye. Crap. Wait, what if we do this? Mm. I should not need this. No, okay, cool. Huh. Okay. There seems to be some problem with passing pointers like this. Wonder why. Right, anyway, I think I'm gonna call it quits too, because I'm getting like kind of dizzy with this all the stuff. Let's see if we can actually raid anybody. Any suggestions? I wanted to raid Yahim, but he's not streaming yet. Unless Yahim, do you wanna stream now? Do you wanna start a bit early or something? Okay, right, so let's raid Raphael, yeah. I think that's a good idea. Yep. Oh yeah, I remember. I was actually meant to drop by his stream to talk dwarf, but I just didn't get time yet. Right, anyway, how do we do this again? Wait, where is the settings? No, content, no. Oh my god, this is, oh, there we go, is that? Right, so thanks everyone. This was great, like proper debugging session. I need to like buy, I need to invest in RR, see what it's like. Thanks for the suggestion. Like I think Andrew did suggest it to me as well, so I definitely need to have a look. Yeah, I enjoyed it as well. Thank you.